Rotational motion, which is a topic. It is a topic. Inception, brilliant topic. So, at the end, is it a dream or is it real?
No, it's real. Movie theory, like he had the ring on.
The ring.
Yeah.
The ring was when it was fake.
Yeah.
Yes.
You said yesterday you were talking about with Mr. Corzine if we were going to move the AP exam.
Yes.
Is it the 5th or the 24th?
Yeah, he didn't give me $100, so I said 24.
Does that mean it's online?
No, should be
It's
paper.
not.
Should be paper pencil.
So why would we not?
He has a few reasons. My reasons, I think, were better. So it's the 24th.
Is it for all physics now?
All physics 1.
Okay.
Yeah, but then
His physics 2, physics C mechanics, physics C electricity. Those are all doing the first day.
Okay.
I feel like that's what I'm looking for.
So anyway,
Smart.
Wait, if I were to take all of the stuff at the same time, I'd have to take all of the
Huh?
the same day, they're like
They're all the same
same weeks.
which is a lot.
All right, so rotational motion. Here we go. What is angular versus translational? Okay. Now, the best thing about this is we already know displacement, velocity, acceleration because we're talking. Okay. We know displacement's x, velocity's v, acceleration is a. But when we're talking about angular, we're going to use different terms. Okay? We're going to talk about theta, omega, and alpha. But they mean the same things as acceleration, velocity, and position. Which is, how cool is that? That is pretty cool. If we can just keep that knowledge in our head, all right? The alpha, theta, omega. Sounds like a fraternity. What?
Reason I'm
Theta, omega. All right. So that is the comparison. And I'm showing you that to try to make a little more sense of what problems are. Okay. And how to solve them. Right? So mainly if you just write down this little chart, that'd be good to go. Okay. Say what?
I'm hungry.
Hungry? What are you hungry for?
Well, I'm about to go into work, so I'll probably have a big fat cheeseburger.
There you go. There you go.
Mr. Bowers?
Yeah.
Where's your pencil shirt?
You know, I had to bring it up here. We were doing. So my physics class, you are my physics class. My chemistry class,
You must talk about us a lot.
we were doing a, have you ever taken Cornell notes?
Yeah.
English class, Cornell notes, where you have a question, you take notes, and then you summarize it at the bottom.
In chemistry?
Say what?
I
Pain.
had to do that.
In chemistry?
Yeah, so we took Cornell notes, which was fantastic, about nuclear energy, nuclear fission fusion. And what it looked like, it was guided notes, so it wasn't bad at all.
What?
Here's an example, but you can like doodle on it. So,
I want a cheeseburger now.
question, take some guided notes,
What time you get
and then there's like a little summary,
After 4 or 5?
but you can like
Just come to the
draw
front.
So we had color pencils.
I opened.
So like doodle notes. Dash
Yeah, I
Cornell
have to
notes.
take some
Which
of
sounds
them.
pretty awesome.
I have to take some of them.
You can just come back.
I will definitely end up doing that.
All All right.
Sweet, why did you?
No, I put some sugar.
We had color pencils.
Oh.
No. Why do you have kinematics on here? Or not, right?
So this is what something might look like. This is what something might look like. Okay. Now, going around the circle, that's our displacement. In other words, theta. Okay. So theta, remember, theta over time is omega, right? Right? Just kind of like distance over time, okay? Right? And then angular acceleration, so instead of velocity over time, we have omega over time.
That's ingenious.
Okay? Just so you kind of, this is just an example of what it will look like.
Wait, is angular acceleration different from vertical acceleration?
I mean,
Or is it just like you said, like a
The-
different?
only difference will be radians.
So
we're
yeah,
doing
if we use
radians
the language
instead.
analogy, this is like using
Absolutely, yeah.
Spanish.
Yeah.
for the same word.
Yeah. Okay. So just that's what it's gonna kind of look like, okay? Just a little heads up. Now, we will be doing radians, which you've probably all seen if you're in pre-calc at this point. Okay, so remember, if that's 0 degrees normally, 0 radians, right? If you go all the way to 180 degree, that's pi, etc. So if you look, if you go halfway to pi, well, it's just pi over 2. If you go a third of the way to pi, it's pi over 3. Pretty straightforward. All right. And then once you go all the way back around the circle, you get 2 pi, 360 degrees. Okay. All right. You good on that? Keep talking on that. All right. So you don't have to write this down. Just a comparison chart. Okay, just a comparison. So we know velocity final is equal to velocity initial plus AT. So similarly, like I'm showing you how all of these equations we already know are the exact same. All right.
We're gonna have to relearn this.
No, we got this. We got this. We've been applying these equations all year long. Absolutely. Right? They're the exact same.
You are really funny.
They're the exact same, except here we have theta, we have omega, and we have alpha. The exact same.
I mean, at least alpha is pretty similar
Similar to what?
They are?
to acceleration because they're both A's.
And velocity is just 2 V's, which is the.
Okay, now thank you for that.
Velocity is 2 V's.
Yeah, and then theta,
That's
just,
definitely
it's
omega.
got a line through it, so.
I mean,
it
we
looks
just
like
already
2
know
lines
what
like
theta
that.
is. Yes.
Is this also true for non-fixed axis?
No. All right. All right. So I think next one's a practice problem. Okay. Here we go. Here we go. We got this. We got this. Just it's like I said. We already know it. Just a different language. Just a different language.
I'm not very good at Spanish.
But this isn't Spanish. This is physics. We
My
got this.
Spanish teacher says hi to me, or she says hola to me every morning, and I'm always like, what do I say again? And I just say the same thing.
You say hi.
Oh, you
I
don't
say
say
hi. I
ciao.
say hola.
Bienvenido.
Like I always get like super like flustered and then I just don't know what to say.
You just stare at her as you walk by.
All right,
Yes,
so
it's creepy.
let's check this problem out.
That's right, balance.
All right, let's check this problem out.
I've been done for 2
What I'm
years.
gonna do is you guys can get a head start. Okay, so ball starts at rest and rotates to the other side in 4 seconds. Okay? If it reaches the other side with an angular velocity of 1.57 radians per second, what is the average angular velocity in this time period? Okay, so to start off, let's write what we know, because that's always a good start. There we go. Okay. Oh, that's example 2. There's example 1. Okay. So, if it starts from rest, all right, we know time is 4. We got that. Time is 4 seconds. All right. Let's see. We know theta. What's our theta? If it went from one side to the other.
180.
1/8. Oh. Pi. We're good. The theta is pi radians. Okay. All right. So we know our omega initial. Right. What's our omega initial? Or in other words, our velocity initial. 0. It starts from rest. We know our omega initial. Do we know our omega final? What's our omega final? 1.57 radians per second. Okay, we know a lot of information already. So it says, what is the angular velocity in this time period? Okay. So what is the angular velocity? Well, what's my angular velocity equation? Angular velocity is, so instead of velocity, instead of distance over time, we have theta. Theta over time.
You're gonna have to give me a second on that.
We're good. We're working on it. Theta over time. Okay, so in this case, we have our theta was pi. Time is 4.
I thought the theta was 5. No, never mind. I'm lost.
No, are we good though?
Yeah.
Don't listen to me or Lynn.
Okay.
Yeah.
Wait, we're doing good though. All right, so pi over 4. Now, if we plug that in a calculator, I don't have a calculator. I do actually. What is pi over 4?
Radical 2 over 2.
No.
Whatever square root is 2 over 2.
What are you?
Is that all the?
What are we trying to find?
Okay. I was saying
That's what I just said.
Okay, I got 0.785, so 1 sig fig would be 0.8. Yes.
Can we just leave it as 5 over 4?
No. All right. So that would be 0.8 radian per second.
Wait, write your 8 again.
We're gonna be the same thing.
Do you write it from the bottom?
You write an 8.
You start from the bottom?
It's the first time you ever noticed that?
Yeah.
Wait, how do you start?
You're back.
No, you all are backwards.
You start from the top right.
No, you start from the top left.
All right. Let me zoom in on how I write my 8s here real
I think
quick.
everybody writes the 8s.
I start in the middle.
I write 2 circles.
Yeah, I start.
Oh, what? You start at the top, you go left.
Oh my god.
I start
It's all backwards.
You start at the top, you go
I
left.
draw a
So it doesn't matter.
Just do that.
They all look the same.
He starts from the bottom left.
Dude, I gotta create a bad snowman.
I don't know. You guys are making me.
Yeah, I have.
You guys are really making me think.
I mean,
How do you guys start?
that's so.
What way do you?
And then it's never like a full
Oh, no, down first.
I go left and then, yeah.
That's how I do it.
I do circle ways.
I don't know.
And then every so often, my body just stops.
All right. So we got our angular velocity. What is our angular acceleration?
Bye.
All right. So remember, acceleration, or in this case, alpha. Alpha is equal to my omega final minus omega initial all over time. Right? It's literally acceleration, just different terms. So my final was 1.57. My initial was 0. And my time was 4. So when we plug this into a calculator, I got 0.4. 0.4. Okay?
I don't know.
Yes.
I have a question. Would we be able to just like leave things in terms of pi, like 0.25 and 5?
No.
No?
This doesn't make sense.
See, because that hurts, because like
Why
in
not?
pre-calc we're taught to leave it in pi.
Can we not change this?
Yeah.
Because you're not.
Because it's way more precise than these sig things were.
You're not particularly solid. So like pi over 4. You're not.
What do you want to break that? In his physics class, he put
Say what?
Huh?
I was probably listening to. You're not fully solid. That's my best thing. Alright, if you leave it as pi over 4,
No.
I see what you're saying, but
So that's literally just what I said. Are you waiting?
it just needs to be written. So it just needs to be in its final
Did you
form.
freak out?
Final.
How many trophies did you get?
Alright, so let's see.
Did you get to the national show?
Ooh. Let's see. My unit. What would my unit be here?
Per second squared.
That per second squared. Very good. Okay. I feel like it wasn't too bad. Okay. Wasn't too bad. All right. So, finding translational with rotation.
Oh, no. I'm scared.
Why?
I don't like this.
It's too many writing.
Too much writing?
There's too many different variables, and I don't like different.
Yes. All right. So the distance. I'm actually gonna write this down. Distance is equal to radius times theta. Okay. Velocity equal to the radius times omega. Feel very official saying these terms. You guys should try.
I prefer to keep my sanity.
Hey, what did you say about my physical science?
I said, what do you want to bet that you put Free Fallin', the song on?
Oh, absolutely.
Yeah.
Yeah.
Free falling?
Just the way
Top
you wrote
heavy?
it. Yeah.
Oh man, I was hitting some John Mayer gravity earlier. Learning about gravity. Oh, it's beautiful.
Did you play the John Mayer version of Free Fall?
I
I saw you over there.
He's
with your
good,
phone out.
but
You were
Tom
like-
Petty in free falling is on beat.
I was like, he's playing Clash.
It's a different vibe.
Now you're playing Clash of Clans, right?
All right.
Oh. He is. Yeah.
All right. So as the last bullet point kind of makes sense. The further the object is from the axis, the more the distance. The more the distance the object travels. All right. So the farther out.
Oh.
All right.
If we were talking something like planets though, or things that was
Mr. Bowers, if this is gonna be on the AP exam, I will bomb the AP exam.
Just started. We didn't even get that far.
That's the problem.
Exactly. I know.
You all are giving up.
Guys,
Well,
I feel like we're doing great already.
This still sucks. Let's not do it. Let's skip this. How much of this? Well, how much percent is on of this is on the AP?
I feel like I am in third grade and you're trying to teach me AP physics.
1 + 1
Because
sophomore year.
So remember, they threw out 8 through 10, so all the percentages went up. So we're actually doing this unit, so it will be 10 to 16%. So probably getting rid of 8 through 12, it's probably going to be about 13 to 20%.
I can get an 80.
Oh.
I mean,
If I can live for one of those.
I found this on
So-
the floor of the lecture
An
hall.
80s?
Someone stole it from a church.
All right. Did we get all that written down? You guys?
Yeah.
Example 2. Okay, example 2. A 4-meter long bar starts from rest and rotates through 5 revolutions with a constant angular acceleration of 30 radian per second squared. How long did it take to make the 5 revolutions? Okay, so once again, as you guys kind of remember with kinematics, you write down all the information you know first. So let's do that. Let's write down, what do we know? Okay? What do we know?
The omega initial 0.
Omega initial 0. I like that.
I have a question. When it says 5 revolutions, does that mean like 360 5 times?
Yes.
Okay.
Okay, so I like that.
2 pi.
So 2 pi 5 times would be
10 pi.
10 pi. So
Okay.
theta,
Alright, now this is kind of making sense.
theta is 10 pi. You know that.
Alright.
All right, so we know my,
You're confused.
let's see, we know my acceleration. My angular acceleration is 30. So my alpha. Oh, that was terrible. I'm so sorry.
Is the alpha
All you have to
symbol
do
like
is
a
draw a
fish
fish.
or without a fish?
Similar.
I'm just gonna be writing A's. I don't know.
So alpha,
A with a little bit of spice.
30 radian per second squared. And we want to know our time. We want to know our time. What equation are we going to use? Yeah.
well, I have a question.
Oh, yeah.
So it says like the 4-meter bar rotates. How does it rotate?
Like which direction?
Like, how are, what, not radius, are they trying to say the radius 4 or the radius 3?
Which axis is it?
I got this.
So is it rotating like this? I'm still trying to figure out the question.
Like, is it,
No, it's angular.
what's it trying to say the radius is?
Oh, right.
Oh, the radius? Yeah. I would say the radius is 4.
It's spinning.
Because if it's here, and if it rotates,
Oh, so it's not like rolling.
no, it's not rolling.
Rolling. Honestly, that's probably why I was so confused. I
So-
was like, I thought it was rolling, so I was like, kick one end of it, and it kind of just like, I was so confused. I was just like,
So we're just like, is it like
So,
a spinning thing?
If we check this out, what equation should we use?
Oh, yeah.
Oh, I don't. Which is?
What's the W?
Okay.
again? Is it omega?
Theta equals theta initial
Is
plus,
it omega?
omega, right? Omega
Oh my gosh, it
initial
looks
times
like a.
Theta is equal to theta initial. Say that one more time. Keep going.
omega initial times
It's done, let's say it's
plus 1/2 angular acceleration.
That is so bad.
Times
So
time
bad.
squared.
What did he say?
Plus 1/2
What?
I said no.
alpha times
No,
squared.
I said something.
Okay, wait.
That's not what I
So,
said.
Why are there
Theta
two
initial.
blocks?
100%.
Oh, this is
So-
speed.
If we check this out, all right, so I like to write delta theta, change in theta, is equal to what's my omega initial?
0.
I love zeros.
I'm also love 0.
Love zeros. So this is 0 right here.
Bye.
Okay, so we're just going to say bye to that. So my change in theta is equal to 1/2 alpha times squared. We can do that.
Yeah, we can.
All right, so my change in theta was 10 pi is equal to 1/2
Well,
alpha is 30
okay.
times squared. I feel like we got that.
If I can use my calculator correct? Yes.
Well, you can use your calculator.
I know. Sometimes I can go.
He's our calculator on the test. I think we all need.
The problem is using it correctly,
True.
because like.
Oh.
I'm not right.
Okay, so I got about 1.45. Okay, so times 1.45 sig fig would be 1 second.
I'm not a fan of this whole sig fig thing. The whole point for it.
I have a question.
Question, love questions.
So would you do 10 pi divided by 15? Or would you just do it?
Yeah.
That's it, and then you do like.
You do the square root of that.
Okay.
All right. So the next question is, what is the angular velocity after rotating the 5 times? So what is our omega final? Okay. So what equation are we going to use here? Oh, I thought Cole had it.
I was checking the time, I'm sorry. It's
No, you're good. Do you want to take a shot at it?
I need to pull out my equation sheet, but I would love to right after. What? Okay. Is it,
Oh my gosh.
I don't know, honestly,
The one on the
I'll be
bottom.
honest.
It's the bottom.
Is it the bottom one? What? It's 30? What's 30?
That was my output.
Just say the one that he wrote on the board.
What did you write?
Maybe this one?
Yeah, that one.
It is
Sorry, the T's are throwing me.
the very first one, the top one.
Okay, yeah, that's
Okay.
ridiculous.
So if we check this out, I'm solving for W. What's my omega initial?
0.
Love zeros. Did I already say that?
Yeah.
I just love them.
Yeah.
All right, so 0. Then we have omega, or oh my gosh. Yep, alpha. Yep, alpha. Alpha is 30. And what's my time? I would use 1.45, correct. Okay? Because that was our official. So 30 times 1.45. I got about 43. Change that back to 1 sig fig would be about 40 radian per second.
Oh, wait, just roll it.
How are we doing?
You know, I wish we didn't have to be using Greek characters. We have 26 letters in our alphabet. And we have more
Now-
symbols.
Did you know Hawaii only has like 13?
Wait, what?
Is it 12?
I'm looking at
It's like,
Hawaii.
I feel like it's.
It could be. I forget the exact number.
I know somebody with a Hawaiian last name.
Really?
Yeah.
How many letters?
Yeah.
I don't know. No, but it's.
Well, that's why
doesn't-
a lot of Hawaii's planets have H, A, I's, O's, U's.
It's 12 sometimes.
It's 12, they have 12 letters. Honolulu, right? They have N's, L's,
All 5 vowels, and then each has 7 random.
7, yeah.
We honestly need more letters.
All right. What time is it?
What?
Andrew, what sound?
What could he have?
Barely remember.
We got time for
What
one.
sound?
We need a letter for
Nah.
Chucky.
What sound?
We got time for one more.
This is not enough.
We got time for
Well,
All right, guys, what's up? What's up?
Stay.
Let's try one more. Let's try one more. All right. So let's check this out. We might see how, we'll see how far we get. A 4-meter bar, long bar below starts with an angular velocity of 40 radians per second and decelerates with a constant rate. It stops after rotating 20 revolutions. All right. How fast is the edge of the bar moving initially in meters per second? All right. So. Let's see. There we go. Okay, so how fast does it initially move? All right, so what do we know? Well, we know
45.
Is it not 40?
40 radius.
so we know my radius. My radius is 4. All right. Let's see. We know omega initial. Okay. It starts with a velocity of 40. So we know omega initial is 40 radians per second. So to convert that, how fast is it moving in meters per second? You just multiply them, right? You just multiply them. So if you look back at our conversions, multiply them. So radius times omega. So I got 160 meters per second. Oh, you can't see that. There we go. A little bit.
Leave a small one.
Okay. So we know. Now let's write what we know. We know my omega initial is 0. What's my omega? Oh. My initial was 40. What's my final? 0. I got ahead of myself there. Radian per second. Okay, so we know those two. Let's see, what else do we know? Oh, we know theta. What's theta? 40 pi. Okay, we know theta. And we got to solve for alpha. That's all we need. What equation are we going to use?
Let me pull out my handwriting worksheet.
Number 3. Very good. We're going to use the third equation. Okay, so we're going to have omega final squared is equal to omega initial squared plus 2 alpha theta. I'm changing things.
Yeah.
My bad. So we're using the third equation. Okay, so final squared, so 0 is equal to 40 squared plus 2 alpha change in theta, which is 40 pi.
You know, alpha.
Are you trying to solve for it?
We're trying to solve for alpha.
Yes.
You said, do we know alpha?
Oh, I thought.
Yeah, it makes sense.
Okay, so plug in this in. 1,600.
That's the only thing I know.
Okay, I got negative.
What's the A? I thought it was supposed to be a fish.
Oh,
Wait, yeah.
my bad. My bad. Even I'm adapting. I'm adapting. So I got negative 6. Negative 6 radians per second squared. All right. Now, if we want to find how far did the middle point of the bar travel, in this one, all we got to do is the distance equal to the change in theta, over times r. Right? Once again, the equation, distance is equal to the radius times theta. So all you got to do is theta times r. So theta was 40 pi. What's the radius? 2. Well, that was my bad. So yes, it is 2. So it would be 80 pi would be the distance.
I thought the radius was 4.
And we can leave it
That was my bad. The radius is 2.
So the
So
radius
then what about the
is
one?
So when you see it, wait, that is confusing.
Well, it says the middle.
The middle point. The middle point.
Oh.
Middle point.
So we can leave it like 80 pi right?
No, 80 pi times
I'm not asking this question.
Further than the middle.
251.
It's in meters, not radius.
All right. So we'll continue to work on this. We'll continue to work on this. All right. I know it's day 1, but we're gonna pick it up. We're gonna pick it up. I feel it. Have a great day, guys. You too. You're doing great.
Yeah.
All right. All right, so hopefully you were able to follow that. If you guys have questions, please let me know. If not, hope you guys have a great day.